Uh-huh. We're going to start with a brief smidgen of series and parallel. Define series, define parallel. Okay. Is that time for you to try it? Series, directly connected by wire. What? Huh. No third wheel. Sure. No third wheel, component, wire, whatever. No junction. Yeah. Two things coming together. No third thing. They're not poly, okay? They're monogamous. Yeah? A couple relationship. You got a third sticking in there, you got a thruple, a polycule. No, no. Series is not like that. Parallel. The definition or a definition that I would like to see is something like connected on both sides. Connected, I should say directly. Connected directly on both sides. Test yourself real fast. Um, oh God, my resistors. These are the worst resistors I've ever drawn. Oh, I apologize. Oh, whatever. Who gives a crap? And for the sake of actually talking about these, just A, B, C, D, A, F, A, G, H, A, E. No. Haha! Caught it for once. Okay, take 2 seconds. Find every series and check it against the definition. Find every parallel. Check it against la definition. Check yourself for your self. You know the squiggles mean more circuit there? The NYs, tildes mean more circuit there. It's not just a wire. Mm, mm, mm. Keep saying no, but I will think about it, Lucas. Well, I'll think about it. No, this isn't anything, Sarah. This is just think for yourself. Think for yourself, sheeple. You're not sheeple. You're people. Okay, okay. I mean, I hope you're people. Be people. I'm a people. No, I'm not a people. So the correct answer for series is BD, EF, and nothing else. If, and this will be like 2 questions on the midterm, just identify series and parallel. Maybe we'll put 3 on. All right. Very important. Why aren't AB? Because there's a junction. C ruins that parallel seriesness. Yeah. Okay. Look for a junction. If there be junction, then they are not monogamous. They are not series. They are not connected directly with no junction because there's yes junction. Parallel. What you should have, I hope, answered is HI and that's it. Yeah? It's clicking? Yeah. It would. The BD combination is indeed parallel with C. I do want to emphasize what I will ask on tests is very precise. I will ask, is this resistor in parallel with that resistor? I do not answer if it is this combination of resistors. Yeah. HI, HI is in series. Hi is in series with G. Yeah, yeah, yeah. C and D are not in parallel. Very good that you're confused about something which isn't true. Wait, you're confused why they're not? Well, they're geometrically parallel, but geometry is not logic in here. Look at the definition connected directly on both sides. CD directly connect on bottom, sure. Is there a direct connection on top? Oh, no, no, no. C and D, there is no word that describes C's relationship with D. C and D are nothing. The junction ruins the possibility of a series, and B ruins their paralleleness. Yeah. Yes. And you'll also have to know the formulas. And there are only three, y'all. V equals IR, series resistors, parallel resistors. I'm not, you can remember that. 20. What? Combos? What do you mean combos? None, 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 zero, zilch, nada. I mean, you'll have to combine and uncombine in your head, or for to find a total resistance or current there. Yeah. No, 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 no. I will not ask for is this in series with that pair. Okay. I hope that this helped settle, solidify some of your knowledge here. Now let's go back to magnetism. Wait, no, 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 no. Right hand roll. Needs practice. Always needs practice. Ah, don't look. Crap. I didn't erase. No, no, no. Don't look. Close your eyes. It's a secret. Okay, real fast. What are we on? Oh, for fork's sake. The freaking form freaking freaked a freaking again. Ugh. Everyone gets 100. I mean, everyone gets 100 already. You get an extra 100, which is 100, but like written specially. So whatever. Try putting these in moving after B. It'll be B, C, D, A, F, A, G. And if you don't know Spanish, wasn't that a prereq for the course? Yeah, do this right hand roll this. Practice right hand roll this. Yeah, yeah, yeah. I want to see how many of the right hand roll is clicking. This is really important. We'll use the right hand roll again and again. Well, look, is there a northeast, west, south, and down and right? So don't answer in northeast, southwest. There's no other cardinal directions there. None of these have northeast, souths, or wests. So you shouldn't use any of the northeast, southwest for any of these. Look, if I ask you a sentence and they're Spanish words and you don't know some of the words, I'm talking Spanish. If I ask you a sentence and there are English words in it, then I'm talking in English. Look at the words. There's no sign of the cardinal direction words. There's no north, south, east, or west. So don't answer in terms of those. All of these are practicing in, out, up, down, left, right. What is that? Out, in. But those aren't questions. Here are the questions. Oh, the symbol. Yeah. Well, I mean, that's important too. Yeah. Yeah. Look at each other's hands, by the way. When you're doing this, seriously, doing this with a partner is helpful. Look at each other's hands and check them. Are the fingers going in the direction of the first vector? Are the palms going in the direction of the second vector? First vector, fingers. Fingers. Point your fingers in that direction. Now, don't move your fingers. Don't change the direction of your fingers when you do the next vector. Rotate your arm. So, for instance, I do down. My fingers are staying down. I'm not going to change them. Then I'm going to rotate my palm until my palm faces left. Which way is your thumb pointing? Which way is your thumb pointing? Nope. In. Yep. In. Correct answer is in. What the balls is balling on? I'm not seeing anyone. Oh, life is suffering. Buddha was right. Life is suffering. New form is fine for this. But I shouldn't be seeing them at all. I hit delete. Oh, whatever. Hey, anyone not remember this at all? Do you want a? Well, you just saw it. I just did it with you.
Not
Oh, you're calculating. You're not. I'll do that in 1 second. But I just want to check, is there anyone who's like absent on Monday or like completely out? Yeah? Yeah? Oh, you're explaining. Okay, good. Okay. So I don't need to like go from the beginning. One. 5% of your grade. Yeah? 1 out of 20. Okay, Isaac. For Isaac's sake. Grace. Y'all who aren't coming to class, this is super highly visual. I cannot both project on the screen and see visually here. I'm sorry. Actually, I'm sorry, but I'm also not sorry. I have warned y'all this entire darn semester. This is not a hybrid class. If you are sick, sure you can come to do Zoom. Please don't come to class if you're sick. But like, I don't think 33 people in the Zoom chat are sick. So my point here is, sorry, not sorry. This is not going to be a very useful part of the lesson for you because I can't freaking do it. Yes, Google YouTube. It's called the right hand rule. Right hand rule. Yes, Google it. But please note there are multiple ways to do it, multiple correct ways to do it. Doesn't matter which way you choose. Learn one and be consistent. Yeah, sure. Out of the page. Stop thinking about yourself. Sure. Okay. I'm facing the board. Something coming out of the board, about to poke me in the face. Maybe you could think out like ow. Like ow, the vector's going to poke me. Okay, yeah? Palm is the second vector. Palm is, yeah, which way? You're slapping someone. Who are you slapping? Person that way. Okay, let's do these. Let's do these. DL. Okay, we're on the DL here. So first fingers, well, fingers, down. Fingers down. Then you rotate your palm. And again, you must not move your elbow now. You can rotate your hand, but you don't move your arm around. Okay, so first fingers down. Rotate your palm until you're pointing in the direction second vector, left. Good, Ricardo, thanks. And your thumb shows the result. Make sure it's sticking out. Which way is thumb? Into the page. Yeah. Yeah? Good. First one, in. Second one, up. Up. Up, cross second vector is in. That's a bad hand position, but let's finish this. Result, left, exactly. Right, cross in. Right, put your fingers to the right. You do the hokey pokey. You put your palm to the in. Which way is the in? Shoop. I am pointing my palm into L page. Which way is my thumb? Up. Left cross down. Whoopity. Well, that's also a bad hand position. Yeah, out. Out of the page. Or ow of the page. The vector's going to poke you. Down, cross, right. Shoink. Wait, yeah, that's the right. Your guys is right. Out. Out. Up, cross, out. Up, cross, out. Yeah. Mm. 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 Out of the page is behind you. I shouldn't see your palm. Yep. Yeah. There is another form, by the way. This is how I was taught. First finger is the first vector. Second finger is give someone the bird. If it helps, if you struggle to see the palm direction, give someone the bird, flip them off. That's the direction of the palm. You like the palm? Okay. Well. Okay. So wait, did we answer all? Did I just answer? I did. Right. Yeah, I did. Okay, we're gonna do next thing about magnetism is I did not emphasize. We learned how to calculate cross. V cross B is the direction same then 0? Is the direction perpendicular then multiply? V times B. And the direction of V cross B is right hand rule. Yeah. So there is a what? There is a algorithm here. How do I cross V cross B? V has a direction. B has a direction. I tell you the directions always. V's direction and B's direction. If they're parallel, no force, no force, no force. Look for that. 0 force. If they're perpendicular, how much is V cross B? Just multiply. And which way is V cross B? Which direction is the force? Right hand rule it. Okay, that's V cross B. But force isn't just V cross B. There's a third thing. Q can be plus or minus. Here's how I want you to do this. Calculate V cross B. V cross B is correct regardless of what Q is. It is the same. It does not change based on Q. You calculate V cross B. Up cross left is up cross left. Then you look. If Q is a plus number, plus left is left. If I multiply left by a positive number, I'm not changing the orientation. If Q is a negative number, what is negative left? What's the opposite of left? It's right. This kills a lot of people, and I think it's because the right-hand rule involves using like 80% of your brain, and then adding one more little step. Kills you? Again, if you got each individual step, this isn't sophisticated. Calculate V cross B. It's that answer. If Q is a positive number, if Q is a negative number, flip your final answer from this. In direction, I'm talking direction. If Q is negative. Yeah. Does that feel okay? We're going to use this in a minute. I'm going to have a fun little extension that actually appears on MCAT stuff and connects back with your favorite module of 111, circular motion. We're going to derive something. We'll get there. We'll get there. It's going to stop telling you what I'm going to tell you and just tell you. Find me a number. Give me a number. Give me a number. No, the number is the answer to this question. I mean, 10 is a great number. This is exercise I. Yeah. Calculate this. Wait, if I say proton, 1 coulomb of protons, 6 billion billion. How much is 1 proton's charge? 1 6 billion billionth. Yeah? If there's 6 billion P's in a C, then each p is 1/6 billionth of a c. In other words, charge of a proton is the reciprocal of that number I gave you at the beginning, really freaking close to 1.6 times 10 to the negative 19. Merry Christmas, there's charge of the proton. Yeah, yeah. If you know the Coulomb number, you don't have to know this. Oh, Coulomb. Just reciprocal. No, because my form is stupid. I don't know what's going on. I stands for I. And no spoilers. No spoilers. I mean, don't tell each other until you're both done. People are listening to the trick. In particular note, I'm not talking about the force vector, just the direction, just the magnitude. Just tell me the number part. How many newtons, not which way. I don't tell you enough to deduce which way. What? Is your internet dropping? Your internet dropping? Huh. Well, my internet is weirding. So how many people are still thinking? Okay, 10 seconds. Chop, chop, quick like a bunny. Okay, so I am writing it down on the screen, what I said a minute ago. Here is the procedure for finding the force that a magnetic field exerts on a charged particle. What is direction one? What did I say first? If what? If direction is parallel, then what? 0! If I move along the field line, am I moving across the field direction or along the field direction? I'm going along. 0 was the answer. You're moving along the line of the field, moving in that direction. That's 0. That's the first case. If you are perpendicular, magnitude QVB, direct hand, right hand rule. Don't forget to multiply by -1 if Q, don't forget to flip if Q is negative. Yeah. This particular one? Maybe. No, I'll test the individual parts. This is a 3-part idea, 1, 2, 3. I try to keep it as, yeah. Okay, here we go. Here we go. Try this. I will also remind you. What? Sure. Parallel 0, perpendicular QVB, right hand rule discover. Sure. You got it? And this is J. J is for Juliet. And my internet is screwing up again. Oh, God, I hate this. I don't know if you guys are, oh, no, I didn't do it right in my head. Never mind. Ignore me. Okay, 1 minute. Oh, look, the answers get better when I can read the screen. I'm not looking for positive, negative. I'm looking for a magnitude here. Don't tell me plus or minus. And I'm not looking 40. What? What? Okay, time's up. Is it 0? No! Moving at 90 degrees, perpendicular. Q times V times B. 1.6 10 to the -19. 1 times 10 to the positive 7, whoopsie. 0.5, Tesla's the unit, so times 10 to the nothing. Okay. I prefer to multiply 1.6 times 0.5. Last I checked, half of 16 is 8. And 10 to the 10 to those multiplying each other just adds the exponent. The last I checked, excuse me, -19 plus 7 is -12. No, 0.8, 10 to the -12. And then I say that's not scientific notation. I don't want 0.8, I want 8 point. All right, so I'm going to borrow a 10 out of the 10 to the -12. So if this goes over 1, that goes back the opposite direction. 8.0, 10 to the -13 newtons. Which, a huge number, got correct. Good job. You're also allowed to use a calculator. You don't know how to mental math or calculate this, whatever. Sure. I wait, quick checkpoint. Google question K. Google question K. Scale of 1 to 5. How you feeling? Like specifically about your learning in here, magnetism in particular. Where are you at? How confident are you? 1 is you're more confused than last year about magnetism. 5 is I'm bored, move on. 7. Oof, sorry. 1 to 5. 5 is I'm totally bored. I understand this completely. Just move the heck on. 1 is I am more confused than I've ever been in my life. This sucks. Everything sucks. Life sucks. Wait, hold on. Someone said 4, but having a hard time. 4 is close to mastery boredom. 4 is you're there. You're having a hard time. I call that 2. Oh, that's helpful. I have 2 goals. I have 2 tasks, I believe. One is I'm supposed to prepare MCAT students for their exam, get all y'all better math skills, and help you challenge you to do something hard and grow as a part of it. And the other goal is to teach everyone, give everyone access to this material, not just teach the top 10% of the class. Most people do not have math, which actually checks with the prereqs. Most people do not have. So those goals are a balance. And I think 3.2 is let's move on. And on Monday, we do more. We do more review. We hit this again. Okay. I have you for another 28 minutes. Yeah, right, yeah. Right? Yeah. I have your brains for 28 minutes. Circular motion. Dun, dun, dun. Okay, so circular motion. Close. Okay, so we're not going to go into the radians. We're not going to go into the frequency and the arc length formula. But I do want to borrow one thing from last semester and hopefully have you think a little bit about the nature of acceleration, particularly if this is something you need to know for life, for whatever. Acceleration is not speeding up, slowing down. It's not only speeding up and slowing down. If you speed up and slow down, sure, you're changing your velocity or accelerating. But any change to velocity requires acceleration. And velocity is more than just speed. Speeding up, slowing down, that's speed. Velocity includes direction. So if you turn, you're changing your direction, you're accelerating. That's what I told you last semester. There is a formula that I gave you last semester: radial acceleration, centripetal acceleration. The magnitude of the acceleration it requires to turn in a circle, or part of a circle, an arc, square of your speed divided by the radius of the curve. If you're doing donuts, the radius of the donut is r, or part of it, any part of that arc. Now, think about this for a second. A charged particle, an electron, moves through a magnetic field. Let's assume it's a uniform big magnetic field. Which direction is the velocity? I don't know, pick a direction. Which direction is the magnetic field? It doesn't matter. Which direction is the force relative to the velocity? Is the force in the same direction as velocity? Is your thumb ever in the same direction as your fingers when you do rigid hand? No. Is it perpendicular to your velocity? Yes. Whenever you have an acceleration perpendicular to your motion, that's causing centripetal motion. Acceleration in the forward direction, speedy uppy. Acceleration in the backward direction, slowy downy. Acceleration in the sideways direction, turny turny. No, you don't like that. Yes. I mean, here's the nature of acceleration. The vector. If I accelerate in the direction I'm moving, someone pushes me on the back, I get faster. Acceleration in the opposite direction, if my acceleration is opposite me, if somebody's pushing them on the front, I get slower. But magnetic field doesn't push in the forward or backward direction on a charge that's moving. Its force, which causes acceleration, F equals ma, its force is at right angles to, right? From the right-hand rule, The force is perpendicular to the velocity. So what does this cause? Circular motion. In general, okay, you didn't buy that? You don't believe that? You checked out? Here's a fact then. A charge moving freely in a uniform magnetic field spirals in general, makes a circle around the field lines. We can use the formulas that we have developed, like this and what we just did, to discover stuff about these circles. Oh, these circles are very real and they're like super. My ham radio setup, I can hear these things. I need to be close to the aurora. This causes aurora. This is part of the particles that cause the aurora are making these. I can't hear them from here. I'm too far south. In my particle physics experiments in PhD, you could just see these suckers all the time, these spirals. This is very real. This isn't just theory. Okay, anyway, let's combine a couple of formulas. If I say that acceleration is v squared on r, how does that relate to the force on the particle? What's the relationship between force and acceleration? F and A? Force versus acceleration? What's force versus acceleration? What's the core equation of all of kinematics? F equals what, A? Okay, now I've got an expression for A. What's A? Was it just on the previous slide? Bada bing, bada boom. I'm going to deduce everything I want from this. And what's the force of magnetism? Assuming they're at right angles, Q, V, B. Oh, well, let's see, I've got a V on each side. Can I simplify? I've got V and V squared. What do I do? So QB, oh, you're such a QB. MV on R. Let's solve for stuff. For instance, there is a classical radius associated with these. If I solve for R, I get radius equals MV over QB. Who uses mass spec? Or has heard of mass spec in their chemistry class? Only a couple? Mass spectrometry? Yeah. Mass spec is huge. Mass spec takes ions with a known charge, +1, right? Ionizes the part of the whatever sample you've got, breaks apart, ionizes the particles. You've got a known charge. You put it in a known magnetic field. That's easy peasy. You apply a known calculatable magnetic field. I haven't taught you how to calculate field yet, but it's straightforward. It measures the velocity is controllable. You can get something moving at a steady velocity. I don't want to go into the how, but it's easy enough to know something's velocity. So what does that say? If V, Q, and B are all known, is the radius of curvature for something moving in a circle able to be seen? Sure. How much stuff moves in that radius tells you the mass of that stuff. If you've got lots of things moving in a circle that size, you've got lots of things of that calculatable mass. This is the equation that is the center of mass spectrometry. This is it, baby. This is its core. We find the mass of particles by breaking apart, ionizing them, sending through a thing, and looking at the path that they take in a known magnetic field. It's quite neat. This is called the cyclotron radius, by the way. You don't need to know the vocabulary. The cyclotron radius is also important. It was first important because if you want to build something that gets particles up to practically the speed of light, all you do is build a circle that's of this size with a known magnetic field. We know the charge and mass of the things we're accelerating. And the bigger the circle, the bigger the velocity. Spirals in and out, gets a little more energy each time, more and more and more and more and more. So this is important to my field as well. Was that the first particle accelerator? Yeah. Look up cyclotron if you're interested. Whatever. There's one more thing I want to do with this and say, what is the velocity of something moving in a circle? Can I relate that to crap? What can I relate that to? What's velocity if you're going in a circle? What path are you moving in? You're moving along the outside of a circle. That's not called a cylinder, it's called a circumference. Right? You move one circumference in one period, right? Right? That's what period means, the time it takes to go in that circumference. Hey, what's the circumference formula? Spoiler. Distance over time. Yeah. You go one circumference in one period, meters per second, 2 pi r over t. Okay. T, what a tease, is not actually, for these cyclotron things, for these mass spec things, for every practical purpose I've ever heard of, t is really, 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 really bitsy. So usually we use the reciprocal of t. What's 1 over period? What does it tell you instead of seconds per cycle? What's the reciprocal? 1 over period is frequency. So I usually write this. I've always seen this written as 2 pi RF. 1 over period becomes frequency. We had, oh, come on, next slide. Cyclotron radius equals mv over qb. What happens if I shove v in 2 pi RF to v? Let's get it. Let's get it. Ow! Oh my, sweet baby Jesus. R cancels R. Gesundheit. Doesn't matter how big the radius is. Different particles will be faster, different particles will be slower. But I could solve. I've got a single expression here. Let's see, multiply both sides by QB. I'm talking too fast. Just a second. I could a known thing multiplied by QB divided by 2 pi m, and I can get what channel do I need to tune my ham radio to listen to the electrons that make the aurora. Well, if I were actually far north enough, the frequency of those cycles, which you can just observe, is all known stuff. Earth's magnetic field, charge of the electron, mass of the electron. You can predict this, and you can measure it, and it's right. Kind of nifty. Okay. So, what am I going to test you on? Yeah? One formula. The cyclotron radius formula. I think is more common. I would love it. I would just love it. It would make me very happy if you can do the algebra to combine QVB and V squared on R and get this. That would be lovely. If you're a pre-med student, that is a level that you should be comfortable with doing that. Push for that. Ask me questions. You need to be able to stitch together formulas like this. But if you need to, Merry Christmas, put this on your equation sheet. If I ask you what is the radius of the circle that this charge at this velocity goes in this magnetic field, there's how you predict it. Questions on cyclotron radius? Hey, quick survey, just raise your hands, not Google form. Who remembered that circles are accelerating? Okay. How many people remember the circumference of a circle is 2 pi r, not pi r squared? How many people remembered what are the other things? Period and frequency are inverses? Yeah. How many people? I don't really expect that you memorized it. V squared divided by r is acceleration. That ring bells. Traumatic bells. Okay. Sorry, the point really isn't to torture you. Well, maybe a little bit. Whatever, plug in. Here, I'm going to give you just one. I will remind you, charge of an electron is negative, although that doesn't end up playing a role. 1.610 to the negative 19 coulombs. Mass of an electron, 9.11, rounding 10 to the minus 31 kilos. What's a micro? What's the symbol? You better know it. I'm not going to tell you on tests. I reserve the right to put these SI prefixes. Micro is millionth. Oh, yeah, do this in Google. L, please. Let's see where you're at. Yeah, thanks, Sarah. Sarah just said, is it an L? Can I go back to where I canceled the R? Can I move back? Is it okay? Yeah. If I just shove in 2 pi RF, Ricardo. If I shove in 2 pi RF, there's an R on either side, it dies. So this happens for particles that are orbiting fast, big radius, particles that are orbiting slow. Small, lowercase. Oh, it means radius. I just forget which is which. Yeah, forget which I use. Sorry. Okay. Yeah. Yeah. Oh, come on. Next slide, freaking punk. I will remind you all that I have given you correct numbers. However, is it possible for a distance to be negative? Are distances negative? I will remind you also the formula that we just deduced. Check your powers. Eh, that's decent. That's good. A fair number of y'all are not converting correctly. Again, mu. The number before the Tesla, there, the T, that means millionth. I suspect that's where well, some of you do. Pretty darn good, actually. Okie dokie. Go home and sleep. Well, don't sleep as you choose. But please, when you sleep, review this in your head. You need to be able to see these. I love you all. Which? For God's sake, there. Listen. Okay. You want to get it? I'm going to close the recording.